Ever since humans came to be, we have always asked questions about our reality. This curiosity we possessed was unique to our species alone, and it is what made us special. As soon as a baby learns to speak, they always start asking questions. Why is the sky blue, they might ask. Or, why am I me and not somebody else? It is questions that let us gather information to create a vivid perception of reality. In fact, this was the entire purpose of science, to ask questions and try to figure out what our reality is and how it came to be this way. Nowadays, we have come quite far indeed. Humans, a small species of life on a small water-filled planet in the Milky Way, have come incredibly close to figuring out reality itself. We can figure out the movements of galaxies and listen to the collisions of black holes without ever leaving our planet. This is, of course, a tremendous advancement from being nomadic hunter-gatherers, but for many, it's still not enough. We have come far, but there are still many more big questions that we cannot answer yet. Among others, some of the biggest ones are, what is time? How did something come from nothing? Is there any meaning to life or anything special about consciousness? And of course, what is reality anyway? Currently, physics just doesn't know any answers to these questions, and only until we can find a successful theory of everything can we know for sure. But what if there was a way around this? Is there something that we are overlooking? Something that can answer most of these questions if we look in the right spot? Well, there just might be. In this video, I will try to explain reality, starting with what happened before our universe came to exist, in the timeless, empty void that is nothing. Part 1. From the nothing. In the beginning, there was nothing. This single line starts many religious books and is where our journey begins. In the void. There is no time, no space, no color. Let's try to imagine it, using a thought exercise by Gavin Giorban. Imagine you are at the very edge of time, at a cliff. There is absolutely nothing beyond it. Imagine crawling to the very edge of the cliff and peering out below, at nothing. Imagine you can touch the very beginning of our universe. Now reach through it. Reach beyond that outermost edge and touch the original void. Feel the blackness darker than black, the quiet beyond silence, the stillness beyond rest. Imagine it. Imagine the nothingness, the abyss prior to existence, and try to feel it. Try to understand it. How do you describe it? Is it frightening or menacing? Is it thick or dark? Warm or cold? Can you describe it? No? Well, maybe your imagination isn't advanced enough yet. In fact, imagination is actually the problem, because what we are describing isn't dark or cold, isn't a void or an abyss, because it simply doesn't exist. Nothingness doesn't exist, so it is nothing. It's impossible to imagine. It's a paradox. And so there are actually two types of nothing: non-existence and the real nothing. Non-existence is simply defined as the absence of things. If you have no milk in your fridge, then there is a non-existence of milk in your fridge. The real nothing, however, is very different. The real nothing is actually the superposition of every possible universe combined together into what is called omega. But more about that later. So now that we have nothing, how do we make something out of it? How did our universe get created from absolutely nothing? Well, first we must edit the question. Since we now know that nothingness doesn't actually exist, the question of something from nothing is a contradiction. It's the ultimate oxymoron. So instead of imagining how something came from nothing, we may ask how our universe came into being from a superposition of all possible states of matter. And for that, we have an answer. Part 2. The creation of the universe. It seems impossible that anything can come from nothing. But in the late 1900s, scientists found something that did. They used powerful microscopes to zoom into a vacuum with absolutely nothing in it. They kept zooming and zooming until eventually they found something. They found that at a very tiny level, trillions of times smaller than an atom, there were particles that seemingly popped out of absolutely nothing. Many people didn't believe that what they found were real until scientists actually measured these particles' force in an experiment called the Casimir effect. Finally, it was proved that the empty vacuum of space is actually not empty, but full of little particles that we now call virtual particles. And in fact, there are actually infinitely many of them in a space as small as an atom. But, you may ask, how can these particles come from absolutely nothing? Doesn't it violate the law of conservation of energy? which states that energy can neither be created nor destroyed? Well, actually, no. These particles sort of cheat the law, because every positive virtual particle also has an equal but opposite negative antiparticle counterpart, so the total energy of the two remains zero. And if small particles can be created out of supposedly nothing, then the universe can too. It has actually been found that unlike matter, which has positive energy, gravity actually has negative energy. And if you were to add up all the energy of the universe, including all of the negative energy from gravity and all the positive energy from matter, guess what you would get? A big zero. The total energy of the universe is shockingly exactly equivalent to nothing. Therefore, a spontaneous splitting of zero into an equal amount of positive and negative energy actually does not violate the law of conservation of energy at all, because technically, no new energy would have been created. And in quantum mechanics, anything that isn't impossible has a % chance of occurring. So although the creation of something from nothing has a very low probability of actually happening, the chance is still there. And I guess you could say it is inevitable. This is called quantum creation, and it's how virtual particles and the universe came to be from absolutely nothing. I will put a link to a video explaining it in better detail in the description below. Now that we have a universe, it is time to witness its very beginning, the Big Bang. Part 3. From the Big Bang to the Big Rip. Thanks to quantum creation, we now have ourselves a point of near infinite energy, a singularity. But it is still not a universe yet. In order for it to become a universe, it must have time. But how does it get that? Well, as I said in my very first video, which I encourage you to check out in the description, time is just an effect of the future influencing the present. Let me explain. In the far future, our universe's ever-accelerating expansion will eventually cause it to expand into absolute nothingness. This nothingness, which is the superposition of every possible universe, has perfect symmetry, and therefore has an incredible amount of symmetry order, which I talked about in my video, The Two Orders. Like a pendulum swinging towards balance, the singularity that we have is drawn to the state of maximum equilibrium, and this is what shoots the arrow of time. From there, our universe undergoes a state of incredibly rapid inflation, and in the blink of an eye, it changes from a tiny singularity to an enormous behemoth, trillions of light years wide. Due to the laws of quantum mechanics and Einstein's famous equation E equals mc squared, the energy quickly cools down and forms elementary particles like quarks, which flow around in a superheated quark soup for a billionth of a second before they collide and form atoms, which form still more complicated molecules, and so on. From energy, the building blocks of nearly everything in the universe, come a zillion different types of particles, as well as waves, fields, and nearly everything else that makes up our reality. And so the Big Bang has finished, and the newly formed universe is now full of atoms and molecules flying around in the expanding space. After that, not much happens for a couple billion years. However, eventually gravity starts combining the freely flying atoms into big clumps that eventually start to burn, creating stars like the sun. Chunks of rock flying around the stars settle into orbit and form planets. One of those planets is our Earth, and on it life begins to form. Quite soon, but also quite late, the first humans, Homo sapiens sapiens, appear, the first life form to be able to wonder about themselves and figure out the secrets of the universe. While all this is happening, the universe is still moving through the set of all possible states towards absolute zero. And as the universe starts to near its goal, it begins to die. The stars begin to disappear, black holes evaporate into Hawking radiation, all while the universe is expanding faster than ever before since the period of inflation at its birth. And in the final moments of the universe, the expansion accelerates to an infinite speed, and all of matter is ripped apart and lost forever. No energy remains. The universe is now back to the timeless, absolute whole of zero. Part 4. To the nothing. In summary, a universe is actually not very complicated and hard to understand. In fact, the only building blocks of it are energy, space, and time. Energy can be obtained through quantum creation, like virtual particles. Space can be obtained through inflation, and time is just the force of the far future influencing the present. From those basic building blocks, you can build yourself an entire universe. There is only one question left. When the universe dies, where will it go? What is nothing? Remember how earlier I told you there were actually two different types of nothing? The first one is non-existence, and it is simply defined as the absence of something. But the second type of nothing is quite different from the first. While non-existence is only the absence of things, the second type of nothing is the absence of everything. It is completely flat and empty space. But isn't space something? Well, not really. As Lee Smolin says in the book 3 Roads to Quantum Gravity, the geometry of a universe is just like the grammatical structure of a sentence. Just as a sentence has no structure apart from the relationships between the words, space has no existence apart from the relationships between the things in the universe. You can think of space more or less as a stage for the universe. It isn't really something, but completely flat and empty space is actually something. In fact, perfectly empty space, the second type of nothing, is the superposition of every possible universe. It is what I call omega. As I said in my very first video, perfectly empty space contains within it the infinitely many possible universes moving from alpha to omega in the set of all possible states. It is zero in symmetry mathematics. Nothing, the superposition of every possible universe, is where a universe came from and where it will go. It is the timeless state of everything. We have come from the nothing, and to it we shall return. Thank you for watching, and I hope you enjoyed. As always, this video was made by Alexander Rafel and edited by Samuel Rafel and Bhavani Gopal-Krishna. The concepts presented in this video were based on the amazing book Everything Forever, Learning to See Timelessness by Gavin Jordan. As always, if you want more amazing and groundbreaking ideas about timelessness, existence, and the true nature of reality, please visit everythingforever.com or buy Everything Forever, Learning to See Timelessness by Gavin Jordan. Thank you for your support, and be sure to subscribe and like this video.